to have a tool like Google Earth, but for the human body, where you could zoom in from a full organ down to its cellular structures. That's now becoming a reality, thanks to the Human Organ Atlas, and physics is at the heart of this project. Physicists have always been pioneers in medical imaging, ever since Wilhelm Röntgen discovered X-rays in the late 19th century. Today we have CT scans that use X-rays to build up 3D images slice by slice, and MRI that peers inside the body using magnetic fields and radio waves. To zoom in closer, medics take biopsies and examine them under the microscope. But the dream of seeing a whole organ or an entire human body with micron resolution has so far been out of the question. That all changed when the COVID-19 pandemic arrived. Back in early 2020, medical scientists were desperately trying to understand what the novel coronavirus was doing inside patients' bodies. Two German doctors reached out to Peter Lee at University College London. They knew Lee was a regular user at one of the world's most advanced X-ray sources, the ESRF.
Max Ackerman and Danny Yonik contacted me in March of 2020 in the depths of the pandemic, asking for help to image the impact that COVID has on our blood vessels, or rather on angiogenesis, the regrowth of our blood vessels. We thought at first we could only do it on small biopsies in 3D, but working with ESRF, in particular Paul Taffero, we worked together and came up with a new technique we call HIP-CT that lets us image not just the fine vasculature in small biopsies, but across entire human organs.
Inside a synchrotron, electron beams are steered around a loop by magnets. As they change direction, they emit X-ray beams that are directed at samples to reconstruct 3D images of their interiors with incredibly high detail and contrast. For instance, an ESRF project in 2011 produced what is still the most detailed scan ever of the skull of an early human ancestor. The new imaging technique that Peter Lee referred to, HIP-CT, has been made possible due to a major upgrade at the ESRF. The Extremely Brilliant Source, or EBS, was completed in 2020. Using HIP-CT, researchers revealed the damage to lungs of COVID-19 victims, a result that can help to understand why the disease can be so lethal. The research collaboration, which now includes more than 50 people, have realised that HIP-CT could be a game changer far beyond the COVID-19 pandemic.
One of the things that we're aiming to do as we develop the technique more is to link our HIP-CT images with incredibly high resolution to clinical images, so like CT scans or MRIs. And what we'll be able to do by linking through artificial intelligence algorithms is to be able to validate ambiguous clinical findings and potentially find new imaging biomarkers that could be used in a clinical setting. So in addition, it's also an incredibly powerful tool for just understanding basic human anatomy. Never before have we got images of organs across these spatial scales in 3 dimensions. And so as a tool for just understanding basic human physiology and what happens to that physiology when it gets diseased, HIP-CT is unparalleled.
Find out more about the Human Organ Atlas in a feature article in the March issue of Physics World, also available on the Physics World website.